In this how-to video, we're going to talk about how to do reflections across the x-axis, the y-axis, and horizontal and vertical lines. So first we'll start with reflecting across the x-axis. So what that means is essentially I'm thinking of my x-axis like a mirror or where I would fold my paper in half. So one thing I like to do, and this is a little big, but I like to dash my line of reflection as like a way of showing this is where I'm making my fold, or this is where the reflection is happening. So you want to picture yourself standing at point A, almost like looking into the mirror that's located here at the x-axis. Or if you can picture yourself taking this entire half of paper and folding it over, we're trying to figure out where this image would go, or where this triangle would go. So if I dabbed a little bit of paint here and then made the fold, I can see that I could go 1, 2, and then I would expect the reflection to be 2 spaces away, but on the other side. So I could put my point here, and remember to use your labels like A prime to show that this is the reflection and not the pre-image. For point B, I could count 1, 2, 3, 4, 5, 6, and so then I'll count 6 in the other direction. 1, 2, 3, 4, 5, 6. So I'm always counting to the mirror and then on the opposite side, and that's going to be the point B prime. And then for C, I'll count 1, 2, 3, 4, and then 1, 2, 3, 4. And so I'll put a point here for C prime. And then I want to make sure I'm connecting with a straight edge or some type of straight lines. And so then hopefully what that looks like is a mirror image of this triangle kind of flipped over on this axis. And so then I could also investigate the coordinates and see what happened here. So the original coordinates of point A were 2, 2, B were 4, 6, and C was 6, 4. And then my coordinates of A prime are 2, -2, 4, -6, and 6, -4. And so hopefully what I can see is that the relationship is that these numbers all stayed the same and these numbers all became their opposite. So when reflecting across the x-axis, there is a formula, which is that an ordered pair goes from xy to x opposite y. And this looks like a negative sign, but remember that we read that as the opposite. So if you weren't drawing the picture, you could use this formula. But again, the easier way to reflect is just to use the counting method. 1, 2, 1, 2. And you can always do that no matter how you're performing a reflection. So on this example here, I'm now going to reflect across the y-axis. That should say y-axis. And so like before, I'm going to dash my line of reflection. And so this time my y-axis is my line of reflection. So I can either think of it as looking into a mirror this way, or as if I was folding this entire half of the paper on top of this half of the paper. And so to start, I'm going to use the counting method. Imagine I had a dab of paint here, and if I were to fold, that dab of paint would end up over here. 1, 2, 1, 2. And so I'll plot that, and I'm going to label it A prime to show that it's the reflected coordinate. For B, I would count 1, 2, 3, 4, 1, 2, 3, 4. And I'm going to label that B prime. And for C prime, I'm going to count 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and label that C prime. And when I connect my ordered pairs, I want to be sure to connect with a straight edge so the shape looks good. And so hopefully we can see how this red triangle, A prime, B prime, C prime, is a mirror image of this triangle here, ABC. And again, I'm going to investigate my coordinates. So I've got my same coordinates as before. A was 2, 2, B was 4, 6, C was 6, 4. And now this time I'm going to list A prime, B prime, C prime. And so my coordinates of A prime are -2, 2, B prime is -4, 6, and C prime is -6, 4. And so this time the relationship is that the x coordinate is going to become its opposite and the y coordinate is going to stay the same. So if you're reflecting across the y-axis and you just wanted to know the coordinates, you could use the formula opposite x, y. This would work. But again, it's always, in my opinion, easier just to use the counting method. 1, 2, 3, 4, 1, 2, 3, 4. So the last thing that I'm going to do is I'm going to reflect this across a new line, and I'm reflecting across the line x equals 1. So this isn't the x-axis or the y-axis, it's the line that always has coordinates where x equals 1. So I might start by coming up with a point 1, 0, 1, 1. Those points are here, and I can see that if I were to connect those points, they would create this vertical line. And so I'm drawing a dashed line there to show that it's my line of reflection. If it had been a y equals equation, it would have been a horizontal line, and I could use the same thing. So just like before, I'm going to count. So A is one space away from the line of reflection, so that means A prime would be one space away on the other side of my line of reflection, and I'm going to label that A prime. B is 1, 2, 3, so I'm going to count 1, 2, 3 to get my B prime. Now what's really important here is that I'm not counting to the y-axis, I'm counting to the line of reflection, which is this blue dashed line here. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and that's going to be my C prime. And again, just like before, I'm going to connect with straight lines to see what happens here. And hopefully what I notice is that this red triangle is the mirror image of this green triangle, and if I were to fold the paper on this dashed line right here, those two triangles would line up perfectly. And I'm not going to investigate the coordinates this time like before because there's no formula when we're doing a horizontal or vertical line. But you can always use the counting method anytime you're doing reflections.